So what is this problem saying? It says prime factor of 13195 are 5, 7, 13 and 29, and largest among it is 29. So what is the largest prime factor of the number this? Okay, so I think as a first step what we have to do is we have to create a function that returns whether a number is prime or not. Basically it should take an input is prime. Okay, so if I just give this number, it should return true or false. Okay, so basically if the number is prime it should return true, otherwise it should return false. So we know number 2 is prime, so we can say that if number is equal to 2, then I will return true. Okay, then we know if number is divisible by 2, otherwise if number is divisible by 2 is higher than 2, then it should be non-prime. So which means if number divided by 2 equal to 0, okay, then should return false. Now for rest of the things we need to check if the number in, basically we don't need to check every individual number because we are already checking if the number is divisible by 2, that is non-prime. Therefore we don't need to check every number. We can start with number 3 and our step will be 2 because we want to check only the odd numbers. However, we don't even have to go until the whole numbers. For example, if the number is 11, we don't need to go until 9 to check the number is prime or not, because you know the 9 multiplied by 9 will be more than 11. So what do we mean by that is basically what we can do, we can check the number if we just go until number square root of that number. Okay, that means number, then I don't want the whole number, I want to cast it to integer, but I'll just go 1 plus and then the step is 2. So if I just go until this and check the if number is divided by I, then that should be enough for us. So the condition here is if number is divisible by I, which means number modulo division I equal to 0. So if it is divided by any of this number, that means we'll start, let's say we want to check the number 25. Okay, that means we'll check 3 to 5, 3 and 5, will not check more than that because 7 into 7 will be 49. So just checking 3 and 5 is more than enough. Okay, that's what we have done here. Similarly, if we want to check the number as 50 or 51, we can check the square root of 50 is it will be 7. So 357, checking 357 is enough. We don't need to check 9, 11, 13, etc. Okay, so if it is divided by this, then we would return false. Okay, now if we have checked all of this number and it is not divided, that means the number is prime, return true. Okay, so that should be our function. So let's test this function. Okay, I'll just remove some space from here so that we get more room. Okay, so let's check, is prime number 3? Yes, it's true. Let's say number 67, it is true. If we check number 68, it's false. So yeah, just like that. If we take say 35, it's false. 39 is false. I think 41 is prime. Okay, so this is working as expected. So what is next? Basically we'll have to figure out what is the largest prime number from any number. So what we want to do is, let's say our number, first number given is 13195. So I'll just define our number as 13159. Okay, now I'll just define a factor, the factor will check whether it is divided by this or not. So again, the factor, I don't need to go until the whole number. I can go until the square root of it. That should be enough. So I'll just say number square root of 0.5. Okay, and I'll say integer, and yeah, I think until that number 5 integer plus 1. And what we can do is, now we have to check because we are interested for largest prime number, we'll just check from the largest number. So basically we'll start from 3 until factor, and we'll go in the reverse order. What I mean by that is for I in range factor, then the last number I'll check is 3, then minus 2, okay, and then if I check is prime, that I, if, okay, so what we are saying, we want to do the prime factor. When I check if the number is prime, then we want to print it, and if this factor is divided by our original number, that's what we want to look for. That means what we want to do is we want to create another condition. If number modular division I equal to 0, that means this. So we are checking the factor for up to this number, and for each factor we are checking if this factor is divided by our original number. Okay, then we want to print that number. Okay, there should be if, okay, if is prime. So okay, let's see what is the factor now. Factor is this. Okay, how could factor be this? Because we are defining factor as, so what is the number? Let's check. Did we take the number correctly? 13195. Okay, that was the problem. Okay, so the number is 13195. Yeah. Okay, so basically what did we get is we got these factors as 29, 13, 7 and 5. If you look at here, that's what it says, 5, 7, 13 and 29, and that's exactly what we got, and the largest among them is 29. So what we want to do is we want to take that big number here. So let me copy everything in a same cell. Okay, let me copy everything in a same cell, just like here. Largest number is this. So basically if you want to say that, if you want to print only the largest number, what you could do is you could create a list and keep track of it, or maybe you can just do like a max variable. Max variable is equal to 0, and you say this, instead of printing you just say if mx is, if I greater than mx, then mx is equal to I. So we keep track of the maximum value, and then what is mx? That's 29. Now what we could also do is we could basically create this as a function. Def get max prime factor. Get max prime factor. Now I'm just passing this number. Now and rest of the things we can do it here. Okay, and at the end we'll just return max. So let's test this function. Get prime factor, that was the number 13195. Okay, so we got 29. So we don't need this. So what we are looking for, we are looking for the largest prime factor of this big number. Okay, let's go there. Let's just pass this number. Yeah, so the answer should be 6857. Okay, let me delete this. So that's our answer, 6857. Let's test this. 6857. Did I copyright? 6857. Yep, our answer is correct. Okay, that's it for this current video. Coming up next is problem number 4.